Any other questions? I can walk.
Thank you. I really enjoy your lecture, but I want to find out, I saw on the instrument that you were taking around calibration dates. And from physics point of view, the sensitivity of any instrument could go down with time. How often do you calibrate or recalibrate your instrument?
We calibrate every single deployment by having that co-located filter. So the calibration date that's talking about that is the calibration that's done at the manufacturer. But these low-cost sensors can get dirty and lose sensitivity with time. And the plan tower is especially susceptible to getting dirty and losing sensitivity with time. We've put plan towers into the New York City subway, which is a horrible, filthy environment. And we can see them lose sensitivity in very short order, as in using them for a week of just going there a few hours a day. But if you collect a filter, it doesn't matter that it loses sensitivity so much because you can correct it back up with the filter weight. Remember, at least for particulate matter, the definition is a mass per cubic volume of air, which is what a filter gives you, assuming that the size separation device, your cyclone or your impactor, is working properly. But, so we calibrate every single time. And that Schreiner publication showed how important it was that you could have a large variation between that gravimetric filter and the sensor response. And that can be because one person could be exposed to diesel soot. Well, guess what? Diesel soot doesn't reflect light nearly as well as crustal Saharan dust. And so it has a very different gravimetric correction ratio if you're just looking at the end members. And humidity can affect it and whatnot. So yeah, that's the answer every single time. For PM, you can't do that for the electrochemical cells. There, you basically are stuck with doing calibrations by going to the lab or by going and hanging out near a reference monitor if someone will let you do that. Did that answer your question? In the back?
I want to find out from the social scientist perspective, what's the visibility of understanding human behavior in relation to wearing or not wearing the device, such as altruism, etc.
Such as what?
Altruism.
Autism. So the question is, has anyone studied personal exposure assessment versus the outcome of autism?
No, the question is, how will you want to relate human behavioral characteristics with whether I want to wear the device or not?
Oh,
because you gave
altruism.
Yeah, you gave instances where children would like to wear a blue-colored device or white-colored device. Yeah, is there a situation where we can relate our human behaviors to the device you are developing? Because technology also has to go with how we use it.
So, this is an issue that because the burden on the participant is so large to wear these devices, we think a lot about explaining, are there any benefits to the participant and are there any risks? And that's also where we come to the issue of maybe a small incentive to give them some compensation for the irritation of wearing the device. But I've had some studies where the students are doing it basically because they're interested in the science. And so they wear it and they want to know what they're exposed to. I've done other studies. I did a biking study where the bikers who've been biking on city streets behind diesel buses really wanted to know what their exposures were on their daily commute. Those bikers did more than any other cohort I've ever done. They changed filters, they charged the devices, they gave detailed time activity reports, they wore crazy blood pressure cuffs to bed, and for 24 hours at a time, 6 different times. So sometimes there's really invested cohorts that will do a lot for altruistic reasons. Other times, it really takes a bit of an incentive, I have to say. It can't be so large to be coercive, but it needs to be large enough that they're interested in it. 3 minutes. Did that answer your question? In the back.
Yes, so I want to ask, the devices were passed by, but I want to,
I think I can hear, I'm actually here a lot better.
okay, so my question is, there was 3 devices passed by, but I want to know how you read data from those devices. Is it by cloud or is there a special app that you read the data from?
Yeah. So the 2 slightly larger devices, there's an SD card that's in it, and you literally have to take the SD card out, download it onto your computer, and then you have whatever data it's logging. On one of them, where it's only collecting the filter, it was logging the flow, and it might now be logging the accelerometry. But those older devices, actually the ones you have there, I'm pretty sure don't have accelerometers built into them. The smaller unit actually does have a Bluetooth, which you can pair to your phone, and you can download it. You don't have to have the phone with the device to make the measurements. And then you can download it with your Bluetooth. In fact, it's the only way you can download it. It doesn't have an SD card that you can get access to. But if you keep it with your smartphone, you can actually look at the data in real time. But now you have to carry the device and a smartphone. The other advantage of carrying the smartphone is it will steal the GPS from the smartphone and log it directly into the file. So there are some real advantages to that. But it doesn't have an accelerometer. For many studies, you don't want them having the smartphone. Why? Because depending on the study, you may or may not want them to know the results in real time. The very first personal exposure study done was on carbon monoxide, and it had green. And they got the results back from the cohort, and they looked at it, and they were like, wow, these people should be dying. They're exposed to such high levels of carbon monoxide. What's going on? And they went and asked, and every single person wanted to see how high they could get the number to go. And so they ran up to the tailpipe of their car, and they held the device there and looked at the numbers. If you're interested in what they're normally exposed to, you don't really want them knowing in real time what they're exposed to. If you want them to change their behavior to avoid exposure, well, then you want them to know what they're exposed to in real time. So it depends on the type of study. But yeah, that smaller, cheaper device of those 3 is the only one that had a Bluetooth connection that would allow truly real time. The other, the one that has a PM sensor on it and a filter, that's continuous. It's not really real time. You get the data at the end when you download the SD card.
Thank you.
But you do get the filter, which allows you to calibrate it. Oh, well, to calibrate it, you still have to weigh the filter in the lab. Yes. So I believe we're late for lunch still. One last question.
I want to find out, do you normally engage the people, or you prepare your thing, go to the community, and then you do the distribution? And if engagements are being done, what are the levels of engagement that you do?
I'm going to allow my partner to talk about that, about the community engagement, because at least for the household air pollution done in Ghana, I'm not here during the engagement. I don't speak the local language. For the studies in the US, we do engage and we give feedback back to the participants. But Mohammed, why don't you?
Thank you for that question. Normally, we have 2 or 3 tiers of engagement. One, you engage the opinion leaders, the community, and then we have individual engagement as well. So you try to build a rapport with a participant, and then they'll buy into it. So the engagement is one of the key activities that has to be done in any research activity before you start. And KH actually does that best.
For the next session. Please, I hope all of you have your lunch sheet. There's a small card that was given to you. If you don't have it, you can't get it. So try, if you don't have it, let me know so that we can give you one. And then when you get there you'll be directed as to what you have to do. So thank you very much for this morning session. Once again. Okay.
Yes.
Please, those of you who are watching us virtually, if you have a question, please post it for us after this presentation. So make sure that if you have any, we'll give about 10 minutes after the presentation, maybe 5 to 10 minutes for those observing us virtually. Okay.
Okay, so the basic idea is we're only going to do the first two, just because the third one would take a long time. So I want you to form into groups of 2 tables. So just turn around and talk to the people behind you and so on, so that there's groups of 2 tables. And then you're supposed to be discussing as a group these 2 basic topics. The first one is, in the communities where you live, what sources of airborne particulate matter are probably well monitored through a small network of just 3 ambient low-cost air monitors? And why do you think these sources would be, sources would be well monitored by a small number of air monitors? And what other measurements would be useful to help interpret the low-cost sensor data? So that's topic 1. Topic 2 is, in your community, what sources of airborne particulate matter do you think would especially need to take into account personal air pollution assessment to avoid exposure misclassification, and why? So you have those 2 topics. Discuss them for about 10 minutes, and then we're going to write down your answers and choose someone to represent your group, because then we're going to discuss them and what each group came up with as their list. Does that make sense? Any questions about the questions? I'll rotate around. If it doesn't make sense, I can try to help. Okay, you got 10 minutes on the clock.